Hello everybody. Alright, we're back. We're in section 14.1 still, and we are still talking about how you find derivatives of trig functions. And really, in this lesson, we're going to start looking at applications of derivatives again, but in regards to trig functions. And I'm going to show you how you find the equations of tangent and normal lines to trig functions. You remember when we were finding derivatives in chapter 7, we talked about how you can find equations of tangent and normal lines using derivatives? Well, same thing if you're using derivatives along with trig functions. You can still find the slope of a tangent line and thus a normal line, and you can find equations of each. We've got two word problems that we're going to work through. Now, lots of information to process, but the concepts you already have kind of within you. We're just going to apply those same things to trigonometry. Alright, we're going to try this word problem first. What I want you to do, well, what we're going to do together is find the equation of the tangent line to the curve y equals cosine of 2x plus cosine x when x is equal to pi over 3. Alright, what I'd like to do first is talk about what are the things that go into the process of finding the equation of a tangent line. Alright, just so we remember, and then we'll go through and actually find those things. And you'll remember that one of the things that you need to know whenever you're trying to find the equation of a tangent line or a normal line is you need to know the coordinates of the point of tangency. Okay, so we know the x-coordinate, pi over 3, for the point of tangency. We're going to have to find the y-coordinate as well. And then the next thing that you need to know is the equation for the slope of the tangent line. Alright, once you've got those things, then you're able to use what you know as far as writing equations of lines to write the equation of the tangent line to that curve. And of course, the way we're going to find the equation for the slope is we're going to use the derivative, and the way we're going to find the point of tangency is we're going to plug in our x value into our original function to find the corresponding y value. Alright, let's go ahead and do that. Okay, so here's the function we're working with, and we're trying to find its tangent line at the point pi over 3. Well, I'm going to go ahead and find out what f of pi over 3 is here so we can find the point of tangency. Alright, so go ahead and plug in pi over 3 into this function. Alright, and you see that we have cosine of 2 pi over 3 plus cosine of pi over 3. And here's where we're going to employ the unit circle. It's been a while since you've used this, right? We're going to use the unit circle to figure out what the cosine of 2 pi over 3 and pi over 3 are. Let me draw the unit circle just so I can refresh your memory on this. Alright, so to recall that pi over 3 is right about there, and 2 pi over 3, right about there. And recall that you care about the x-coordinate for that point whenever you're trying to find the cosine. And the x-coordinate for that point at pi over 3 is 1/2, comma, square root of 3 over 2. Alright, and then of course at 2 pi over 3, it's negative 1/2, comma, square root of 3 over 2. So, cosine of 2 pi over 3 then is going to be negative 1/2. And the cosine of pi over 3 is positive 1/2. And so you get 0 for the y-coordinate for the point of tangency. Okay, let me label that over here to the side, and then I'll clear some space for us to do some more work. Alright, there in the right-hand corner, you've got the coordinates for the point of tangency. Now let's work on finding the slope, the equation for the slope of the tangent line. For which we're going to need to know what dy dx is. Alright, we're going to use the rules that we learned in the previous video here. The cosine of 2x, its derivative, would give you negative sine of x times 2. So negative 2 sine of 2x. Okay, use the chain rules there. Go back and double check the work if you need to. And the derivative of cosine of x is just going to be negative sine x. So there we've got the equation for our tangent, for the slope of the tangent. And if I want to find the slope of the tangent for when x equals pi over 3. Now I need to find out what f prime, basically, of pi over 3 is. So, that's going to be negative 2 times the sine of 2 pi over 3 minus the sine of pi over 3. Now we just drew our unit circle a little bit ago, and if you've forgotten what the values are for the y-coordinates for 2 pi over 3 and for pi over 3, you can go back and rewind that. But turns out the sine of 2 pi over 3 is the square root of 3 over 2. And so is the sine of pi over 3. And if you have negative 2 square root of 3 over 2 minus 1 square root of 3 over 2, then you've got negative 3 square root of 3 over 2. Alright, so trying to summarize what we've learned so far about this line, we've found the point of tangency, pi over 3, 0. And now what we've found is the slope of the tangent line at that point. So all that's left for us here is to go ahead and write the equation of the tangent line using point slope form. So y minus y1, which y minus 0 is just going to give us y, is going to equal the slope of the tangent, negative 3 square root of 3 over 2, times x minus x1, or x minus pi over 3. There's the equation for your tangent line. Hope that all makes sense, because it's all what you've done before. It's just with trig functions now. Alright, one more example here in this video. Let's take a look at it. Got another function f of x for you to consider, and we're going to say that f of x is equal to 2 tangent of x. And we're going to look at that over the interval from 0 to 2 pi. And what I'm wanting us to do here is find the value or values of x for which the normal lines to the graph of f are parallel to y equals negative 1/8 x minus 1. Alright, so let's think about what we're told here and have a plan for how to proceed. We know that this function has normal lines that are parallel to the graph of y equals negative 1/8. Well, so what that's telling us then is that the slope of the normal lines is equal to negative 1/8, which means that the slope for the tangent line is going to be equal to positive 8, right? And we want to find the values of x for which this curve f of x equals 2 tangent of x has a tangent with a slope of 8. Make some sense? Alright, so let's proceed and do that. Just rewriting the function so we've got it in front of us, and rewriting the fact that we now know that the slope of the tangent line is equal to 8. And let's see how we can find out the values of x for which that would be true on the interval from 0 to 2 pi. Okay, so the slope of the tangent is equal to 8, meaning that f prime of x has to be equal to 8. So if we can find out what the derivative of f of x is, we can set that equal to 8, and then we'll have our answer. Right, and f prime of x is going to be equal to 2 over the cosine squared of x. Alright, so set those two things equal to one another. Alright, and if we're going to solve for x, then we want to multiply both sides by cosine squared of x first. So that'll give us 2 equals 8 cosine squared x. And then if we divide both sides by 8, we're going to get 1/4 is equal to cosine squared x. And so cosine of x, cosine of x would equal plus or minus 1/2, right? We need to consult the unit circle again here. Alright, remember we already said at pi over 3 the cosine of an angle is equal to 1/2, and we also said at 2 pi over 3 the cosine of an angle is equal to 1/2. But we also have to consider the third and fourth quadrants here. At 4 pi over 3 and at 5 pi over 3 we also get 1/2 or negative 1/2 for the cosine. Okay, and since each of these values solve this equation when we set the derivative equal to 8, that means these are the values of x for which the tangent line would be parallel to that other line whose equation I gave you before. Our answers then, there are 4 of them on the interval that we're looking for. We'll go and summarize those right now. Alright, and so that's how you use tangent and normal lines in regards to trig functions. Excellent. Still some tough problems for you to try. Good luck with them.